And now the third speaker comes from a firm who has not yet worked in Italy, 3XN, but we hope it will soon happen, Christian Veddeler.
Can you hear me? Or not yet? Oh yeah, now it starts. Just waiting for the slides. Thank you. So, thank you very much for having me or having us here. We represent 3XN and GXN. We always come as a pair of two. 3XN being our architecture branch, GXN our embedded innovation entity, which is important in the project I will show in a few minutes. We are based with our headquarters in Copenhagen, but we are also internationally present in 3 other continents. We are in New York and Sydney, in London, in Stockholm and in Amsterdam. I will keep it short. We are a practice of 220 people globally and have a very strong focus on the one side, design excellence, but on the other side, maybe I started to introduce this already with GXN, something you could describe as evidence-based design. So what we try to do is in early design stages to get as much well-educated information that helps us and our clients to take well-educated design decisions, which we think is extremely important, seeing the sustainability responsibility that we have as architects. Oh, this is the old first slide. I sent you guys a shorter version. This is the long version, so I have to improvise a little bit. Transformation of a tall building is the story of today. I will focus on one specific project as a case study, the Quay Quarter Towers in Sydney. And it also could be called reuse of a tall building or adaptive reuse or renovation. But I think transformation is the more correct term because it has to do with a radical change. I think the slides are now changed. Try to improvise, tell you about transformation. So it has to do with radical change, transforming something from a condition into something new. And this will be the case with a project that I will show. Before I go there, I give you a little bit of a dry background, which I think is necessary just to give a context of this project. Bear with me. So, exactly, there we are. The discussion, namely, which also brought us deeply into the project I will show today, is how do we build? How do we used to build and how do we still build? Which is very much driven by a take, make, use, dispose approach. Taking land, for example, taking resources, scarce materials, energy, to make, to design, to pre-construct, to construct a building, to use it during a very often limited lifespan, and then to dispose it when we realize that the building is not for our use anymore. And we all know that the idea of abundant resources is probably very limiting because we don't have the luxury position to be in a world of abundant resources. Economies of scale is the question, so how often do you need to rebuild? How often do you need to focus also in terms of development short-term profits? Because all of those mindsets have heavy environmental, economic, but also social impact. So the question again, how do we build? Is built-in obsolescence a key driver of the buildings that we still produce today? Because this take, make, use, dispose approach provides really no sensibility to elongate building life cycles, right? To focus on the reduction of waste generation, to focus on the reduction of environmental pollution and of resource consumption. And as I mentioned before, obsolescence, very often driven by depreciation, which is just an accounting model, calculating down a project, an asset to zero. Maybe there is still a very high use value in it, but in the books it has zero value. It is aesthetic drivers, which make a lot of sense. Of course, we are careful to engage ourselves with beautiful buildings. That changes. Fashion is an important aspect. Technical importance, that systems, we see this obviously very evident with MEP, for example, or facade performance, they age, need to be removed, and functional aspects of buildings are taken into consideration as well. The important thing is that buildings, or the construction industry, which is for most important product, buildings, is contributing quite a lot to negative impacts of, for example, waste generation, of global greenhouse gas emissions. The use of energy, the use of materials is gigantic, and therefore we think that it's time, maybe in our limited capacities as architects, to contribute to at least try to improve the situation. And as I said now, this take, make, use, dispose approach is deeply embedded in a linear economy approach, right? Which has a limited lifetime perspective, which is disregarding any end-of-life stages after use or consumption. The opposite to it, and of course, it's a buzzword, it's used many times, it's the circular approach. So circular economy, to doing quite the opposite, to take into consideration end-of-life stages, in particular of buildings, and what to do with this. So the question here today, I would like to illustrate with a case study I will show in a few minutes, is can we decouple building from finite resource depletion? Can we change our perspective from building design to a building life cycle design? And the case, as promised, now some more friendly and more entertaining pictures, hopefully. It's not the project on the right side in front of the bridge, it's this one. It's a high-rise building in Sydney that we have completed basically this year. It's a QQT, Quay Quarter Tower. And the interesting thing, having introduced the story about circularity, is that it takes into consideration the reuse of an existing, you can see this on the left side, existing high-rise building from the 1970s. This is the AMP headquarter. It's an almost 200-meter tall tower. It's a typical modernist building, and it has reached its end of its life cycle. So the question was what to do with this. Together with the client, the conclusion was early taken in 2014, which was quite interesting for us to be, let's say, forerunners in that sort of thinking, to use that existing building as much as possible and embed it into a new plan. So what you see on the right side are two different grays. The dark gray is the part of the building that has been removed in order to make the central core accessible for construction purposes, to extend twice the amount of the floor area to it as an extension. As I mentioned before, this has to do with transformation. So this is not a refurbishment, this is not a renovation, this is a radical transformation of that building with quite some effort, but taking into consideration the existing building to a large degree. What you can see in those diagrams is the existing building on the right side, trimming it back to the central core and extending a significant amount of square meters that even would allow to introduce large-scale void spaces that would be so different than the typical stacked plan of the 1970s building. So just some numbers, always important to evaluate the stuff that you're doing. 65% of all existing structure could be saved, including slabs, columns, and walls. 98% of the existing core could be saved, while doubling the amount of square meters and saving 130 million Australian dollars that otherwise would have been invested if this would have been a completely new build project. Important output also, 2,500 tons of CO2 have been saved. This is an abstract number, but becomes more evident if we see that it's the equivalent of 5,000 flights from Copenhagen to Sydney. So just to give you a scale and a certain sort of proportion to it. What we found when we looked at this building was, as I said, this typical modernist building with pretty depressing lowered ceilings and installation floors. Even going to the corner office didn't make this impression much better. What was good though was the existing grid, was the existing structure, the existing core, the condition of the material, the condition of the construction that was ready for radical transformation, to be used and to become something new. Also, a key component here, the floor-to-floor height, was significant enough to reach a proper clear height while allowing the introduction of new MEP systems throughout. What I show you in the sequence of floor plans is just the idea behind. We have this existing core, we have the extension, and what we could do, we could increase the efficiency of the floor plate significantly by doubling it, by just adding 4 elevators and 1 scissor staircase. So the core was not growing in the same proportion as the floor plates, which of course every developer loves. And what you can see at the extended part of it is the introduction of circular stairs for void connections. And what happens throughout the development of the height of the tower, the floor slabs are shifting vertically, which gives not only the building its pristine character, it also is a site-specific constraint taken into consideration, which is the orientation in two directions, the harbor bridge and the opera building, looking across-site the existing building in front of it, which is a little bit an obstacle, but part of the family, because it's also from AMP, our client. And you can see pretty much what I'm talking about. On the right side, the opera house and the harbor bridge at the back, which make also this design very site-specific, and this building connected to its neighborhood context. Here you see the harbor bridge a little bit better, with cut off the other building. And of course, what this shift of floor plates is generating is the provision of outdoor garden areas, which we all know after COVID is a big plus for state-of-the-art working environments. Additionally, in opposition to the existing floor slabs that were just stacked, we have the possibility to introduce, and these are pictures from the realized building, vertical voids that work more as dynamic working spaces, as social points, amenities that support the working environment, and are also becoming a certain sort of local vertical neighborhoods in the building, break down the scale of this massive high-rise, and allow interaction. At the same time, they provide daylight capacity, obviously, in deeper parts of the buildings, which again is lowering energy consumption for lights. So what you can see is this driver. It's a comparison maybe of a 1970s typical modernist building and our proposal that is introducing vertical connection that is appreciated visibly, but also through transportation you can go up and you can connect different floors that otherwise would have been separated. And this is a principle that sort of vertical neighborhoods, as I mentioned before, that become the backbone of the building in the extension part and do not only connect local stacks of office floor slabs, but basically all the way down integrate the site, integrate to the surroundings on the ground floor level that is at different heights. You can see this in that section, and allow a certain degree of porosity horizontally with a neighborhood context on ground floor level and vertically up the building. And here's some impressions of how this looks inside. So we also think that there's a boost in a new approach of a typology of a high-rise building. And I hope that the animation is working. This is the construction process, which I think is illustrating the project. So scaffolding goes up, parts of the existing building are torn down. It's way too fast. You can see that the facades in parallel are going up. And here the final result, some drone videos that give a good overview. What I would like to emphasize here again is we have to do with a transformation project that takes into account the structural, the technical, the embodied carbon strategy of reusing an existing building to the largest extent possible and transforming it into a state-of-the-art office building that we think becomes an icon for the city, and maybe also an icon for embracing the idea of reusing existing buildings. Thank you.